My name is Hannah and this is about the dependent samples t-test. By watching this tutorial, you will easily understand what a dependent samples t-test is, how you can calculate and interpret it, and what the requirements are. And at the end of this video, I will show you how you can easily calculate this t-test online with Datatab. If you want to look up the topics of this video, just take a look at datatab.net. There you will find all the informations. So let's get started. The t-test for dependent samples tests whether the mean value of two dependent samples significantly differ from each other. What is a dependent sample? In the case of dependent samples, the measured values are available in pairs. The pairs result, for example, by measurement repetitions with the same persons. Let's look at an example. Let's say you want to find out if vacations have an influence on the stress level of people. In order to analyze this question, you have created a small online questionnaire with datatab.net. By using this questionnaire, you ask people before and after their vacation about their stress level. There are now two ways to do this. Possibility one is you interview a group of people before they go on vacation, and then you ask another group of people after they come back from a vacation. In this case, you would have an independent sample because the people you interviewed before the vacation have nothing to do with the people you interviewed after the vacation. The second possibility, and also the better possibility, is you ask people before they go on vacation and then you ask the exactly same group of people again when they return from their vacation. In this case, you would have a dependent sample, so the measured values are always available in pairs, so you have two values for exactly the same person. So therefore, if the people have nothing in common with each other, you have an independent sample. If the people you ask before and after are exactly the same people, the measurements are in pairs and you have a dependent sample. In this case, the t-test for dependent samples is used. Before you can calculate a t-test, of course, you must formulate your hypotheses. In the case of the dependent t-test, the null hypothesis is there is no significant difference between the means of the two dependent groups. And your alternative hypothesis would be there is a significant difference between the means of the two dependent groups. Therefore, one hypothesis is that there is no difference, and the other hypothesis says that there is a difference. Of course, it's also possible to formulate directed or one-sided hypotheses. Then the null hypothesis would be one sample has a significantly smaller or equal mean value. And the alternative hypothesis would be one sample has a significantly larger mean value. Of course, the smaller and larger can also be reversed depending on your research question. How does the dependent t-test work? Of course, we'll look at this using an example. To recap, the dependent samples t-test tests whether the means of two dependent samples are significantly different from each other. Let's say you want to test whether a diet program developed by a celebrity really has an effect on people's weight. To do this, you find individuals who are willing to follow the diet program. You measure the weight of the test persons once before and once after the diet program. Since you measure the weight of the test persons once before and once after the diet program, the measured values are always in pairs, and that's why you have a dependent sample. Your null hypothesis is the diet program has no significant effect on the body weight of the participants. And your alternative hypothesis is the diet program has a significant effect on the body weight of participants. Of course, you could also make directed hypotheses. Your alternative hypothesis then would either be the diet program significantly reduces the weight, or the diet program significantly increases the weight of the individuals. But enough about these hypotheses. How do we calculate the t-test for independent samples? First, you start by weighing each test person once before and once after the completed diet program. We are not interested in the weight before and after, but we are interested in the difference between before and after. So for example, how much a person has gained or lost weight. Therefore, we calculate the difference between before and after for each person. By doing this, we have converted the two paired values into one new value. By this conversion, we have made one dataset out of the two datasets. Now that we only have one dataset, the t-test for dependent sample is equivalent to the t-test for one sample. Let's say the first person gained 3 kilos, the second lost 4 kilos, the third one lost 7 kilos, and the fourth person gained 5 kilos. So on average, the participants lost 0.75 kilos. Now the big question is whether the diet is responsible for the fact that there is a difference, or whether this difference occurred by chance and the diet has actually no influence. To answer this question, you now need the t-test for dependent samples. Now some of you will certainly shout, "Stop! What about the requirements? Don't we have to check them first?" That is absolutely correct. However, first I would like to explain the basics to you by using an example, and then we will go into the requirements. To calculate the t-test, there are now two possibilities. Either you calculate the t-value by hand and compare it with the so-called critical t-value. We will look at this in a moment. Or the second way is you simply use a statistics software as Datatab and let it calculate and interpret everything automatically. I will show you how to do this online at the end of this video. So let's start with the calculation by hand. We want to calculate the t-test, but how do we get to the t-value? In order to calculate the t-value, we first need the number of cases. We have 4 dependent pairs, so we have 4 cases. The number of degrees of freedom is the number of cases minus 1, which makes 3. We calculate the mean of the data simply by adding up all the values and dividing them by the number of cases. This leads us to the mean value of minus 0.75 kilos. Next thing we need is the standard deviation. For this data we get a standard deviation of 5.84. By using the standard deviation and the number of cases, we can now calculate the standard error of mean, which is 2.84. The standard error of mean tells us how much the mean would vary if we had taken quite a lot of samples. This means that the larger this value is, the more likely a large weight gain or loss will occur by chance, because there is simply a large variation in the mean. So, and now we can finally calculate the t-value. The t-value is the mean minus 0 divided by the standard error of the mean. Why 0? Our null hypothesis says that there is no difference, so we want to test if the mean is significantly different from 0. Now we need to check whether the amount of this calculated t-value is smaller or larger than the so-called critical t-value. We can find the critical t-value in a table. But how does this work? We have set a significance level of 5%. If we are testing an undirected hypothesis, this would mean that we split the 5% between the left and the right side. So we have 2.5 on the left and 2.5% on the right side. Therefore, in the table of critical t-values, we need to look at 97.5%. This is what we get by subtracting half the significance level from 1. So we are in this column right now. The degrees of freedom in our case are 5 minus 1, which makes 3. So we are in the table in this row. So the critical t-value is 3.182. We've calculated a t-value of minus 0.26. Therefore, the critical t-value is greater than the amount of the t-value that we have calculated. If the magnitude of the calculated t-value is less than the critical t-value, the null hypothesis is maintained. The table with the critical t-values can be found on datatab.net, and you find the link below in the video description. Our null hypothesis is the diet program has no effect, and the alternative hypothesis is the diet program has an effect on the body weight. Our calculated t-value was smaller than the critical t-value. Therefore, based on these data, we retain the null hypothesis and assume that the diet program has no effect on body weight. So let's start with the first assumption now. There are two dependent groups or samples. As the name t-test for dependent sample suggests, the groups must be dependent. For example, a value of one group must belong to a value of the other group. The condition is fulfilled, for example, if the weight of one and the same person is measured before and after a diet program. However, it's not fulfilled if the weight is measured from persons who have dieted and from other persons who have not dieted, and the persons are not related to each other. Assumption 2 is that the variables must be metric. In the t-test for dependent samples, the difference of the two dependent values is calculated, and then we calculate the mean. Of course, this only makes sense if our values have a metric scale level. A metric variable, for example, is a person's salary. A non-metric variable would be a person's educational attainment. Let's look at the third assumption now. The third assumption assumes that the differences of the paired values are normally distributed. So this means that the differences between the paired values required for the paired t-test must be normally distributed. It could, for example, be that the weight of different people has a normal distribution. An example for no normal distribution would be the difference of the number of eyes after throwing 2 dice. And now I will explain to you the second way, which is how you can calculate it online with Datatab. In order to do this, just Google Datatab, click on the statistics calculator and copy your own data into this table. Then select this tab and click on the variables you want to analyze. Datatab recognizes that there are dependent samples and automatically calculates a t-test for dependent samples. You can also choose whether you want to test an undirected or a directed hypothesis. Further, Datatab gives you the hypotheses, and if you scroll down, you get the results. Here you can read the p-value. If the p-value is smaller than your defined significance level, for example 5%, then the null hypothesis is rejected based on the available data. In this case, the p-value is 0.197, which is greater than 0.05. Therefore, the null hypothesis is retained. Furthermore, you can also check the assumptions and get an interpretation in words. The score before vacation had lower values than the score after vacation. A dependent samples t-test showed that this difference was not statistically significant. This results in a p-value of 0.197, which is above the established significance level of 0.05. Therefore, the t-test result is not significant and the null hypothesis is maintained. This means that it is assumed that both samples are from the same population. I hope you enjoyed the video. If you like, just try Datatab. It's very easy to use. Bye and see you next time.